Up to where we did last time? Anyone can recall me?
Sir, isolated node.
Isolated graph. Okay. Keep your MATLAB on.
Sir, I am having a doubt, sir. Can I share my screen?
Yes, you can say.
Right. Sir, can you see my screen?
Yes, it is visible.
Okay, sir. In the last practical, there was a sub part of to find the degree of node.
Yes.
So this was the graph I have plotted, and I found degree g, right? I have given the function degree of g.
Hmm.
So
Okay.
if I'm considering node wise, then let us take node number one. Then this particular node number one is having degree of 3, right? So there will
Correct.
be a one connected edge right over here, then second one right over here, and then it is going to the fourth node. So degree is 3, right?
Correct.
Looking at the consideration of the second node, again the degree will be 3 because it is going into the third node, and then two connections of this node number one.
Okay.
But if I'm thinking of the node number 3, then node number 3 must have a degree of 3
No, self loop you have to
because
consider twice.
self node I have to consider twice. Why? Why is
Yeah.
that, sir?
Because at present it is not directed graph. It is any not incident or adjacency. It is undirected graph.
Okay, so for self node we have to mention degree is equal to 2.
Yes.
Okay, sir. Quite fine.
Shall we start?
Yes, sir.
Yes, sir.
Okay. So this is the experiment number 1. Probably we try to finish this also today. And up to next Friday, you have to upload this experiment on LMS. If we are able to complete today. So graph theory, what we started is also the part of the theory class where we need to write down some algorithm in such a way that in MATLAB, at least we can write some codes to get the feeling of all possible algorithms. Because once you are using the any cadence or mental graphics tool, you cannot change the algorithm. Whatever input, only you have to rely on the output. But this algorithm writing we are using in MATLAB, and MATLAB inputs always require some graph theory concept. So we are using this graph theory concept to implement some complicated algorithm later on. So we completed up to the isolated vertex, something like that. Let us today number 1 again. I am starting. The new one is pendant vertex. So it is a graph. It has a vertex with degree of 1 only. So in any graph, if you find any node whose degree is 1, that node is called the pendant node or pendant vertex. Node and vertex synonymously used. So in any graph, if you find any node whose degree is 1, that node is called the pendant vertex pendant node. So you have to implement one graph in your MATLAB, and out of, let's say, 5 node, any one node has only 1 degree. So that node is called the pendant node, pendant vertex. Will you try?
Yes.
Okay.
So can you repeat, please?
In any graph, okay, in a graph, it is a node with degree 1. Let's say there are 5 nodes, but out of 5 nodes, one node has only 1 degree. So that node is called the pendant vertex pendant node. Do not see this circuit. You try with yourself.
So done.
Done.
Yes, done.
So in chat box, write down 1 done, so I can see your chat box as well. Yukesh, can you share? Yukesh, Yukesh, roll number 1118. Node number 4. Okay, node number 4 is pendant node. While
Yes, sir.
all
Node number 4.
okay, good, good. So
Okay, okay, sir.
whenever you use your manual for writing, I expect all students have some different answer. It's not like similar. All 18 answers are similar. So then it is difficult to find out, give the weightage. Now in this diagram, which gate is pendant gate? Which gate?
Or three. Three.
Yes, your answer is
Three.
correct. 3 is the pendant vertex pendant node. Correct. So remaining student, they just use chat box to complete the answer. Number 2 of today, we go for null graph. No age and no degree. It's a graph with no edges and all the node have 0 degree. It's a graph with no edges and all the nodes have 0 degree. Try. The graph with no edges and all the nodes have 0 degree is called the null graph. Please do not take one node only. Take multiple node. Karan Singh, you did 1 or 2?
Sir, 1.
Okay, so now go for second. Someone mic is on.
Sir, can you repeat the second one?
Second says that it is a graph with no edges and all the nodes have 0 degree. Edge है ही नहीं तो degree 0 ही है. Something like this in digital.
So can we take three terminal or only 2?
Pardon? Terminal?
Means 3 variable.
You can take any number of nodes, no problem.
Okay, sir.
No edges, no degree. Null graph.
So done. So done.
Oh, very quick. Let me ask you to share your screen. Yukesh?
Yes, sir.
Yes, you can share.
Is it visible?
Yes, it is visible. But what is T, target?
So
Target is
null.
T.
No.
Always any graph has a source and target. Use some target and then make it edge 0, degree 0.
So all the nodes have no degree.
No degree.
Okay, sir.
Just stop sharing.
Sir, can I?
Yes, you can share. You can share. So again, same. There is no source. How it is target? Define some source also. Stop sharing. Define some source, Jamin. You can stop sharing.
Sir, can you explain one-time pendant node?
Okay. So if this is a graph, with 4 nodes, fourth node is somewhere here. So node number 4 is called the pendant node, whose degree is 1. This one. Or if you see this logic diagram, this gate number 3 is pendant gate. Is it clear? Hello?
So degree must be 1 in pendant node.
Yes, degree.
Okay, sir.
क्लॉक का आपने पेंडेंट देखा होगा. क्लॉक जो आती है ना, वॉल क्लॉक, पेंडेंट जो होता है उसमें जो क्लॉक टाइम होता है इसके हिसाब से वो घूमता है लेफ्ट साइड एंड राइट साइड. सो इट हैज ओनली 1 degree. Now try for null graph. there is a one function in MATLAB. It is called RM. RM stands for remove and age. It has a three variable, your graph, your S and T. So it remove the edges, all edges. So now your task is easy. तो पहले कोई एक ग्राफ बनाइए, फिर इसमें एज रिमूव कर दीजिए. So it is look like this library of your. So take one graph and remove the age. That's it.
Done.
Can you share your screen? Let me. I stop my sharing. Now you can share. Someone said that done. Pujan is sharing his screen. Okay, 1, 2, 3, 4, S, T, G, S. T. Can you show me the graph plot G also? Okay, good. Pujan. Kunjan, can you share your screen? Kunjan have to share her screen. This is look like library of our standard cell or logic gates as a null graph. By applying physical design, we have to do the connection based on the applications. Gunjan, can you share your screen for second one? Okay, Sumit, can you share your screen? Sumit. Okay, Sumit.
Yes, sir.
You did also same one. Okay. Okay. Let's move ahead. So this is null graph normally defined to for the library where all standard cells are there. Let us go for next third one. Connected graph. A graph is said to be connected if there exist a path between every pair of nodes. A graph is said to be connected graph if there is exist a path between every pair of nodes. Path is available between every pair of nodes. That is called connected graph. A graph is said to be connected graph if there is exit a path between every pair of nodes.
So executive means
पाथ होना चाहिए between every pair of nodes.
yes, sir.
पता नहीं सच है रमेश सच अनिश जो किया वो ट्रू है वो पता नहीं है
चलो
यहाँ
शेयर
पे
करो. Let us see. Ayush done.
सर मैं शेयर करूं?
Yes, yes, you can share. Pujan is sharing. Let us see Pujan. It's not connected. There is no path available between 1 and 2. There is no path available between 2 and 3. There is no path between 3 and 4. It is not connected graph. No path between
So,
5 and 6.
so can I share?
मैं शेयर करता हूं सर.
Oh, yes, student can share. Ayush, maybe Yukesh is sharing. Someone listening a song. So this is UK's screen. There is a path between each node. Yes, correct. Correct, UK's.
So I'm not listening the song. There is song on there is a temple. Navratri function is going on.
Okay, no problem.
Okay, yes, sir.
Can I share?
Yes, you can share. UK's, you stop sharing, so other can share. Ayush is sharing. Only few students are answering. I will ask anyone. Yes, this is correct. It's a connected graph. कोई भी नोड बाकी नहीं रह जाना चाहिए. All nodes should be
Yes.
connected. Good. So only 1, 2, 3, 4, 5 students done. Saurav is sharing. Yes, correct. No problem. Correct. So if there is a connected graph, disconnected graph is also there. It's defined like this. It's defined as a graph is disconnected graph if it does not contain at least two connected nodes. Disconnected graph is a graph. It does not contain at least two disconnected nodes.
does not contain two disconnected nodes at least.
It does not contain at least two connected nodes. This time I
Can
will.
you repeat disconnected
The definition, yes, disconnected graph is a graph. It does not contain at least two connected nodes.
Sir, can I share via camera?
Yeah, let me. You are not using your laptop or what? Now you can share. Better if you share your screen. One, two. Go to the graph. Okay. Correct. Correct. Correct.
Okay, sir.
So 4 is done by 3 students. So disconnected graph
Sir,
is
can
done.
I
This
can
way
I share the
also.
screen?
This is also disconnected graph. Yes, you can share. Yes, correct. For connect.
Connected graph.
Yes, disconnected. Correct.
So
Correct.
meaning of at least two connected nodes, that means does not contain at least two. That means minimum it does not contain at least two connected nodes.
So yes, to join the two nodes, you require at least one edge. That's why.
Okay.
Okay. Now can you stop sharing? Now this is very important. We are going to go for the number 5. Remaining student also continue with your 1, 2, 3, 4. This is one circuit. Okay. Let's say this logic diagram. Suppose I want to enter this logic diagram as an input. Okay, so first I will sketch the graph of this logic diagram. So this 1, 2, 3, like that. This is 4 and 5. These are my 5 nodes. So 1 is connected with 2, 2 is connected with 3, 4 is connected with 2, and 5 is also connected with 3. So which gate is doesn't matter in your algorithms, because we are going to minimize the interconnection and everything. So this I have to input in your my algorithms. So I have to generate, let's say, matrix A. So whenever connection is there, you just simply write down +1. If there is no connection, you write down 0. Can you generate that matrix?
Yes.
So try for this.
Sir, can you explain it more?
If connection is available with, let's say, between 1 and 2, connection is there. So between 1 and 2, you have to write your matrix should contain 1. If there is no connection between 1 and 5, that value should be 0. That kind of matrix you have to generate. That is called adjacent matrix.
Sir, in MATLAB we have to generate or we have to write on some paper?
You have to write down the code to generate this matrix. So first make a graph. From the graph, the function is available in MATLAB. It's called adjacency. Adjacency of graph. So it will generate some values.
So can you explain it one more time? I didn't understand anything.
So if connection is available between two nodes, here 5 nodes are there, connection is there between 1 and 2. So your matrix, that element A12 should be 1. There is no connection between 1 and 5, so A15, that value should be 0 in the matrix.
Between 2 and 3 also there is not there, so it is 0.
2 and 3, it is connected, so 2 and 3 is somewhere here. That value should be 1. And 3
Okay.
also 1 because both are connected.
Okay.
Likewise, that is called adjacency matrix. Function is adjacency of graph G.
Done, sir.
Very quick. Let us see your answer. Can you share? This is number 5.
Done, sir.
Someone said that done. They have to share. Oh, okay. As Eswari, you can where you can share your screen. 101 number. Oh, you are using pen and paper. But why not using MATLAB? Karan, you are not using MATLAB?
Sir, now trying in MATLAB. Yeah.
Okay. How? Okay. Now you are trying in MATLAB. Okay.
Yes, sir. Oh.
Eswari Tiwari 101. Can you share your screen?
Sir,
This is graph, but where is a agency matrix?
sir, adjacency, and it is like this written here in the
So
bottom.
have you verified that it is coming according to that nodes?
Uh, yes, sir. 211 like that.
Okay.
So
If
is
you
it
if you
in the
want to
for?
if you want to generate the matrix, add one more command. It is called, let's say, variable b. B equal to fu double l full into bracket variable of adjacency full of, let's say, a.
Sir,
Can
can
you?
you share the screen once?
Okay. After adjacency, let's say the adjacency variable is a of that graph G. Okay, this G is nothing but graph of S and T.
So
So
got it.
let's say, okay, full of A, you will get entire matrix, this kind of
Yes,
thing.
sir.
Got it.
Okay, good. Let me other to try.
Sir, what is B equal to?
B equal to FU double L A, full A. Let me write again. Both are same. Roll number 115. Can you share your screen? 115.
Yes, sir.
Sir, I have completed up to this agency, but that full that one is not getting properly.
If you write down the like this B equal to full H, you will get this kind of matrix. See the screen. So there are 5 nodes in this screen. 4, 5.
Okay, sir.
1 and 2 is connected. So at that place you find the 1. 2 and 4 is connected. 1, 2, 3, 4. Yes, there it is 1. Okay. Okay, Nirali.
Okay, sir.
If you've done this number 5, let me give you the one circuit. For that, you have to generate the adjacency matrix.
Yes, sir. Done.
Okay, let me finish my circuit. Can anyone tell me this graph we use in which design of which step in the physical design?
Partition.
Yes. So remaining student generate the adjacency matrix for this diagram. 1, 2, 3, 4, 5, 6, 7, 8 node.
Sir, numbering we have to consider by ourselves or we are doing
By yourself,
state number.
by yourself. So let me ask Gunjan, can you share
Okay, sir.
number 5? Exercise number 5. Gunjan, can you share?
सर वो वाला फिर से दिखाओ ना एक बार स्क्रीन शॉट.
अच्छा वो circuit.
Yes.
Okay. This one. This is also same exercise, but you have to generate adjacency matrix. Let's say C. This we can give as an input to the partitioning. Give the number according to your choice.
Done.
Okay.
Sir, done.
This is 6 1. This is 5 1. I think. Let me check. 5 or 6. Okay, it's a 5. Second part of the 5. Oh, can you share your screen to see the result? So whenever we start the partitioning chapter, which is chapter number 2, circuit partitioning, we start with this kind of graph if logic diagram is given. Yes, correct. Okay, correct. Good. अभी एक बार एक किसी ने भी शेयर नहीं किया, ऐसा कौन सा स्टूडेंट है? लेट मी चेक, जिसने अभी तक एक भी बार शेयर नहीं किया. 112. Can you share your screen? Then
Yes, sir, I am doing that exercise. Just a minute.
okay. 111. Jamin Rawal. Can you share?
सर मेरा लैपटॉप हैंग हो जाता है जैसे ही शेयर करता हूँ ना.
अच्छा, okay, no problem.
Can I share?
Yes, you can share. This act as a input to the partitioning block. So when we start the algorithm, we take this graph which is equivalent to logic diagram. Yes, it is correct.
Sir, can I share now?
Yes, you can share now.
Okay. Is it visible?
Yes, it is visible and it's correct also.
Okay.
Let us move ahead.
Sir, don't know why I am not getting the metrics. Can I share?
Yes, let me stop my sharing. Yes, you can now share.
So I also have the same doubt as Ayush has. I'm also not getting the graph.
Okay, let us see first,
Is it
Ayush.
visible?
Wait a second. Yes, now it is visible. So B equal to full plot A, plot B. You have to plot B. No, plot A. Okay. So remove the semicolon after full A. Matrix is there.
It shows the error.
Sir, there is a G na?
हाँ G चाहिए. किसका G चाहिए?
Full G.
No, correct.
Sir,
इसका G.
interchange A and G.
So abaya matrix.
Matrix is there.
Sir, there is a full in counts. There is a G na?
So A is graph of ST. Then G is a variable for adjacency. Where is the problem?
Interchange A and G. Sir,
Yes, interchange A and G.
Now plot G na.
Not, it's A. Full
No,
of.
not that, not that.
E full.
Okay.
Where is matrix?
Is it okay?
Where is matrix? Matrix is not there.
Just a minute, sir.
Sir, hello.
Yes, sir.
Transaction कर दिया कर.
Now it is here. Sir.
I found something.
Plot G, plot G, plot G.
Plot G, not plot
Okay.
A. Now, can you run one more time?
Oh, yes, sir. Yes, sir.
Okay, correct. Can you stop sharing?
Yes, sir.
Anybody want to share their screen, or shall we move ahead? Anyone, student? Okay, let's go ahead. Next is isomorphism. You have to plot two graphs, let's say graph G1 and G2. The number of nodes are same in both graphs. There are three conditions. Number of edges should be same in both graph G1 and G2. And number three is that if I am interchanging any two node, still graph remains same. I repeat, you have to generate two graphs G1 and G2 where number of nodes are same, number of vertices are same. यहाँ पे 5 है तो यहाँ पे भी 5 होनी चाहिए. Number of edges are also same. And third condition, if I am interchanging any two node, let's say V1 and V2 in graph G1, and also in graph G2, V1 and V2, the graph remains same. Graph should not be changed.
Sir, last point clear नहीं हुआ.
So let's say there are two nodes in graph G1, the number is 2 and 4, V2 and V4. Let's say I am taking other number. V2 and V4 are the two nodes in graph G. Okay. And that same node also somewhere there in graph G2. Okay. So now if I am changing in graph G2, let's say for example, if I am interchange this 2 and 4, still this graph is matched with G1.
Sir, one more time explain the one.
Okay, let me explain. There are two graphs G and H. Okay. So the first condition, number of nodes should be same. Number of edges should be same in both graph. And third condition, let me put in another way. Equal number of nodes with given degree. Equal number of nodes, I put another way. Equal number of nodes with a given degree. सभी नोड की डिग्री भी सेम होनी चाहिए. Ayush says that put some complicated. This is okay, no problem, but take few more nodes.
Done, sir.
Can you stop sharing? Take more nodes, Ayush.
Sir, Karan is sharing.
Oh, Karan is sharing. Okay, can you take more nodes, not just two?
Sir, can I share? Okay, sir.
Ayush is sharing. Okay, 1, 2, 3, 4, 7, 6. Oh, correct. Absolutely correct. So function is isomorphism between G and G comma H. Yes, correct.
So is it correct?
1, 2, 3, 1, 2, 3. Okay, correct. The function is isomorphism between G and H. You will get new variable. Let's say P is a variable. Isomorphism between G and H. So you get node number where you can interchange the node number. Some number will get, let's say 1, 2, 3, 4. So 1, 2 you can interchange 3, 4 like that. Still graph remains same. Can anyone tell me these two are same? These two graphs are same?
Yes, sir.
Correct. Now try for this. These two are same?
No, sir.
No, these two are not same.
Degree different. I think.
Ah. Okay, so we'll take a break of 10 minutes. We'll join soon after 10 minutes. We continue more exercise after break. Am I audible?
Yes, sir.
Shall we start?
Yes, sir.
Okay, start. Next is very important concept number 8, which is called tree, that we are going to use in the second step of physical design, which is called the floor plan.
Sir, I am having a doubt.
Yes.
Sir, in the isomorphism graph,
Hmm.
you have mentioned more shapes like a square and two triangles are connected together back to back.
Hmm.
So in the first problem, how these two are equal, square and two triangle pairs?
So you have to count number of edges, number of vertices. You have to
Okay,
count.
that means we are not bothering about.
Incoming, outgoing, that we are not looking. We are counting number of edges, number of vertices.
Okay, sir.
So 3 is very important in the floor plan representation. Let me give you one floor plan in this die area with some number. This 4, 3, this indicates which are the block, or after the partitioning we get this number, and one by one we place this all box on the floor plan, something like this. So this is the output of floor plan. If you want to optimize this floor plan with some algorithm, definitely you have to represent this floor plan in the form of the tree. So can anyone tell me which one is the first bisection, horizontal or vertical, in this entire floor plan?
Horizontal.
No.
Vertical. 4.
This one. If
Or
you
3.
see, yeah, complete. So by looking this floor plan, we have first is the vertical bisection. It is bisect into again one horizontal as well as horizontal. Which horizontal? This horizontal is my 3 and 4, and this horizontal is my 2 verticals. This one. This vertical is divided into 2, 1. One is 7 and 5. This is divided into horizontal as well as 2. Just look the floor plan. This horizontal is divided into 2 horizontal, 1 and 6. This is called horizontal, which is the vertical of horizontal of 6, 1 and 2, which is the vertical of 7, 5. This is the horizontal of this. Will you get this? This is one way to represent the floor plan.
No, sir. Why we are going for vertical first?
Because if you see the without any box, okay, first bisection is this complete bisection. First bisection is complete bisection is vertical. That's why I first go with vertical.
Okay, sir.
That vertical has 2 horizontal. Okay, one horizontal is this, which contains 3 and 4, and second horizontal is this one, which contains 2 vertical. This vertical, which is 7, 5, and second vertical, this one.
Sir, we have to always take vertical line.
Pardon?
First vertical line.
First vertical line. Why? As what you are asking?
Yes, sir. वो जो पहले आपने लाइन ली ना सबसे बड़ी वाली, फिर वर्टिकल आपने
ये वाली,
तो
हाँ. So if you see this black box, nothing is available in this one. And if you see First complete bisection is vertical. That's why I put here vertical.
तो सर अगर हॉरिजॉन्टल होता तो हॉरिजॉन्टल लेते.
Suppose first bisection completely is like this. Then you have to start with horizontal. Something like this, whatever.
तो सर अगर सपोज हॉरिजॉन्टल वर्टिकल दोनों एक ही जैसा दिया हुआ है तो कौन सा लेने का.
मतलब horizontal and vertical is given. If any this is either horizontal or vertical. It is not complete horizontal and complete vertical. Never possible.
Okay sir.
Sir, if there are two verticals then.
Pardon?
So if there are two verticals, complete two verticals then.
Complete two verticals. So you start with one vertical and assign second vertical with remaining what available. You can do that way also. There are many ways to represent this floor plan. Let me give you one more. There are some rules you have to follow, but I am not discussing any rules at present. Just to represent it, how it is look like. Can you try for this? So first is vertical. Which this is one of the possibility, okay? Which is divided into horizontal of 2, 1. Just follow the floor plan. Then vertical. Then it is divided into horizontal. Horizontal is 4, 6. Sorry, 4, 3. And this is horizontal with 5. One of the possibility. Then 7, 6 is my one. One of the possibility to represent this floor plan like this way.
And sir, second one.
Second possibility. Okay, let me sketch other possibility also. This is vertical first, horizontal, vertical. This is 2, 1. This is V, which is H. Just I interchange the 4, 3. Here I am changing something. H, 7. This H is my 6 and 5. This is one more possibility. Third possibility is like this. V is the vertical of V and H. Then it is a horizontal of 4 and 3. Then it is horizontal of 2 and 1. Just follow the floor plan. Now it is 7 and H. And it is 6 and 5. One of the way. All three correct. Will it be okay?
Yes, sir. Sir, can we make more than 2 branches in one horizontal or vertical?
More than 2.
Yes, sir. Sir, like 5, 6, 7 in one horizontal.
No, this is the concept of tree. This is the concept. This all are called the tree. ये सब tree है. So tree has always one root and two branch. Tree has always one root and two branch or two
Okay,
leaves.
sir. Okay, sir.
So this tree definitely we will use once we have floor plan, which is the second steps of physical design. So let us write some MATLAB code for this. First, you give me the one root like this. Write a code to generate this graph. This is called tree. If possible, put the arrow also. No problem. This is called tree with graph of the tree. It has no circuits or cycles. It has no circle, no cycles, nothing. Karan, you did which one? This 8 number. Just write down number also. 8 done. Then number 9 is rooted tree, where its graph is like this. Just you have seen previous example for the floor plan. This is called rooted tree. It has many vertices with many leaves. Try for this number 9 also, which is called rooted tree.
Sir, can I share the screen for tree?
9 done.
9 done. Very quick. Yes, you can share. Someone said to share.
Or is this tree?
No message is there, but screen is not. Yes, now it is visible. Okay, correct. Very simple it is. 1, 2, 3. Now go for rooted tree. It has many leaves. But single node has a 2 leaves. That you have to take care.
Sir, can you share the rooted tree again?
Yes. So next number 10 is defined as a binary tree. It says that, try to listen this definition. One vertex has degree 2, while all remaining vertices has a degree 1 or 3. Only one vertices has a degree 2, while all remaining vertices has a degree either 1 or 3. That is called binary tree.
Ten done.
Can you show
Done,
me?
sir.
Can anyone show me?
Is it visible, sir?
Let me check. No, it's not correct. Node number 2 has how many degrees? See, 1, 2, 3, 4. It is not there.
Sir, node number.
I said 1,
Okay.
2. You're getting that?
Okay. Yes, sir.
Either 1 or 3. Not
Okay. If I will remove this, now is it okay?
now it is correct. Correct. Now it is correct. Okay. So let us move for next one. Someone can stop their mic. Parthiv, mute yourself. Now I am giving some answer. This is my tree. Number is also there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Suppose in this graph, if I want to move to the number 7, so which path I have to follow? That is the question.
1, 2, 7.
Hmm?
1, 2, and 7.
1, 2, and 7. Let me just give me 1 minute. There is not clear visibility in the graph what I have. Let me just check the correctness. There is some invisibility in the graph. Let me take one more.
So what is the name of the graph?
This is the tree representation with multiple lips. Let's see. Okay, let me give some other number. 3, 2, 4, 5. This is 6, 7, 8, 9. The 11 number, the title I will give you after some time. Don't worry. 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Let me check number again. 1, 3, 2, 4, 5. Okay. Then 6, 7. Okay. 6, 7, 8, 9, 10. From the 9, 16, 17, 18, 19, and 20. Now we have to find the path. This is you have to find the path or distance from top or surface. From, you can say, from top to bottom by picking any number. By taking any number, you have to find out the path from top to bottom. So let's say I pick the number 2. I pick the some number and you have to find out the path from that number from top to bottom. So I pick the number 2. This is 2, 6, 7, 8, 9. 2, 6, 7, 8, 9, then 16, 17, 18, 19, 20. Just follow me. 6, start from 2, 2, 6, 7, 8, 9. With 9, then 16, 17, 18, 19, and 20. Then 10, 11, 12, 13, 14, and 15. You have to start from top and then you have to move bottom. This kind of algorithm is called depth first search, DFS. Depth first search algorithm is to find out the distance from top to bottom. Depth first search. DF search is a function in your MATLAB of graph G. Let's say here we are looking for two numbers. If you are looking the number 9, okay, so 9 distance is 16, 17, 18, 19, and 20. No any other connection. If you are here looking at present 2, so it is 2, 6, 7, 8, 9, not in horizontal line, it is moved down 16, 17, 18, 19, 20, then back to the 10, 11, 12, 13, 14, and 15. It's moved from top to bottom. Depth first search. Used to find out the distance
Sir,
between. Yes.
सर ये ग्राफ में लास्ट नोड क्या होगा तो हमारा?
1, I repeat, this is 1 which has 3, 2, 4, and 5. This 2 has multiple 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This 9 has a multiple 16, 17, 18, 19, 20. Last one is 20. So if you write df search in your MATLAB, okay, and then you enter, you will get this number 2, 6, 7, 8, 9, then not 10, it is 16, 17, up to 20, then again 10, this 10, up to 15. Depth first search algorithm.
सर मेरे में 1 3 4 ऐसे आ रहा है.
You have to first make a graph.
ग्राफ बन गया.
Same similar kind of.
सर सेम आ रहा है.
Which one?
So 2, 6, 7, 8, 9, 16, 17.
20, up to 20. Then 10, 15, up to 15. Is it correct? Can you share your screen?
Yes, sir. Yes, sir. Yes, sir.
Okay. 9, 10. Yes.
So 2, 1, 3, 4, 5, 6, 7, 8, 9, 16, 17, 18, 19, 20.
So let me give you to you who's doing same. Can you stop sharing?
Okay, sir.
Let us waiting for chat box for others are doing or not. Meanwhile, you try for this diagram. Search for 2. Remaining can do first for this one. And show me in chat box. 11 done, Karan done, only 2 student done.
I have a question.
Hmm.
So what is the purpose of 2?
It says that if you want to reach to the 2, you have to follow this path.
Okay, sir.
If you are getting answer for 11, try for this 12, for this sequence.
Sir, in this where we have also search, we equal to BF search.
In which case, 11.
12.
Breadth first search. It is there. BF search. Yes, you are correct.
Okay.
Breadth first search. Side by side distance measuring. Breadth first search. Side by side distance measuring. So that it follows this path. 2, 6, 7, 8, 9, 10 in sequence. While depth first search follow top to bottom, not side to side.
Sir, not able to understand. What is BFS?
Breadth first search. It's measure distance side by side. So if you see 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, like this, side by side. While depth first search measure top to bottom. So same graph, if you write BF search for 2, it will give this answer. BF search.
In 12th one, we have to perform BFS.
Yes. To get this sequence.
For 2.
For 2.
बीएफएस का फिर से बताओ ना क्या कैसे सर्च करता है वो
इसका 11 या 12?
12
12 measure the distance side by side. If you see, if you pick up number 2, no number 2, so it start with 6, 2, 6, 7, 8, 9. Then it not jump to down. It cover all the side by side. 9 के बाद 10, then 11, 12, all side it's connected. Then it move for the next 16, 17, 18, 19, 20. While in case of depth first search, it first look the down. So 2, 6, 7, 8, 9, then not 10, it is 16, 17, like this. So depth first search, breadth first search.
सर 2167 आ रहा है सर 2167
हाँ सर सेम 2 आ रहा है
2, 6, 7, 8, 9, 10, 11, 12, वही sequence. BF search, G2.
सर बीच में 1 आ रहा है
सर 1 आ रहा है बीच में
और 6 के बीच में
सर वो स्टार्टिंग पॉइंट 2 ले रहा है
आपकी क्या आ रही है sequence? 2, फिर 1.
हाँ 2
सर
1
216 2167 8 9 10
अच्छा 1 बीच में आ रहा है ऐसा.
यस सर और सब सेम है
बाकी सब सेम है.
यस सर
Let me check.
सर ये 12th वाला जो है ये राइट साइड में जो ग्राफ है उसके लिए करना है
हाँ यही ग्राफ के लिए, सेम ग्राफ के लिए.
अच्छा
Yes.
ग्राफ या डायग्राफ जो यूज किया है ना, शायद उससे फर्क पड़ा है।
There is no use of diagram. This is simply
नहीं सर, मैंने डायग्राफ लेके किया है तो बीच में 1 नहीं आ रहा है।
सर आप ग्राफ लेके करोगे तो अलग आएगा, डायग्राफ लेके करोगे तो अलग आएगा, ऐसा मैं बोल रहा हूँ।
सर 1 नहीं आ रहा बीच में।
in the case of diagraph. With the use of diagram.
यस सर।
यस सर,
Yes, sir.
डायग्राफ में 1 नहीं आ रहा बीच में।
वो उल्टी डायरेक्शन में नहीं जा रहा।
Because of in the undirected graph it move up also, because 2 is connected with one side, like 10 11. If you see the 2 without arrow, 1 is also there, like 10 11. So for this you need diagraph, you need arrow for the proper sequence. So diagraph is there instead of graph for brief search algorithm, brief first search algorithm. So instead of graph, use diagraph. Otherwise 2 is also there with 1, like 10 11. It will not distinguish. Use diagraph instead of only graph. Shall we go for next?
Yes, sir.
Let us share my screen. Suppose this is my graph, one of the graph. I'm not giving number at present. This is one graph. Can you say only one connection is available between each node? Is it true or not true? What do you say? Let's say this is my logic diagram. Only output of this gate is connected with this NOT gate. No any other input is received over here. Is it like that? Because circuit is too complex, it's not like always that only one connection is there. This node also receive the signal from any other branch or any other gates, maybe like this. So in that case, we have to assign some weight to this alternate. We have to assign some weight for all the nets. Weight is larger, it means you can say it is strongly or it is connected multiple times. Strongly is a good word. Weight is large, it means it is strongly connected. Weight is less, it means it is lightly connected. So assignment of weight is also the concept in the graph theory. Let's say I am assigning 2, 4, 9, 1 like this. So whenever I will try to optimize, this is very strongly connected. So I have to apply some algorithm first to this tightly connected net. Where so many interconnection is there, like this. Not a single wire between, but other connections are also coming on the same net. So assignment of weight is the next step, that is called weighted graph. Weighted graph. All the edges you have to assign with some weight, like 2, 4, 1, 9. that indicate it is lightly connected or strongly connected. So can you make this kind of weighted graph? Let us see who will do. Take simple graph, assign weight on the net, which shows the connection, whether it is tightly connected, strongly connected, or loose or lightly connected.
How to assign weight?
Take 1 minute, otherwise I will tell you definitely. Try to use some programming concept. It's nothing.
Okay.
Let me give you the hint. So take some variable, let's say W, which is the weight, and take some number, let's say 1, 2, 5. That is equal to number of edges. And try to plot the graph. This is the hint.
So done.
Okay, Pujan, can you show me your result? Can you share? There is a weightage of 10 marks of this experiment. So more you are showing, more weight you will get. If you remain silent, there is probably to get the less marks. Where is the number weight? Weight should be there on the graph.
W then
W you have taken 10, 1, 10, 1, but in your graph it is not there.
one second.
So this is the last one that you have to also add in your lab manual. Use some programming concept, definitely you have an answer. So this I am left for you, all 18 students. You have to display the weight on net, not simple graph. Can you stop sharing? Someone share this screen. Pujan.
Sure, 1 second.
Okay, no problem. Your camera is on, Pujan. So this all today's 13 and previous year, last week, some 6 to 7 MATLAB code, and it's screenshot you have to attach in your manual.
So when we have to submit this?
This you have to submit before next Friday. You have full 1 week time. Next week we start with the second experiment.
Okay, sir.
Next week we start with second, but before that you have to submit. So before 2 p.m. next Friday you have to submit.
Okay.
Weightage is 10 marks. Whatever exercise we did, this 13 and last time we did 6 to 7. All together 20 or 21. With MATLAB core, small MATLAB core, and the screenshot result of MATLAB. Do not sketch with freehand and then copy paste, not like that. Whatever result you displayed in the MATLAB screen, take the screenshot by snapping tool.
So done weighted graph.
Okay, I will like, can you share?
Yes,
So
sir.
done.
Don't worry. Keep your code with you. Okay, do not share the code. Share your screen. But anyhow, code will be there.
Mm, Using camera won't be there.
Oh, camera. So number will be there. I am not able to see exactly.
Yeah, 4, 10, 9.
Oh, then it's fine. Then it's fine. Correct. Good. Yes. Anyone else? Your super senior got 10 out of 10 in one of the semester and examination. I wish you also try in that way. Her lab manual is very clean.
Sure.
Conclusion, proper conclusions you have to write. Do not just write, do not use I and we whenever you write the conclusion. Try to relate your answer with physical design where it is used. Yes, correct. It is weighted. In all the course, you have to prepare a manual. So 75% is from this 10 experiment, 25 during your LPW exam. So small MATLAB code you have to write, then you have to paste the figure window. So it is better whenever you are doing the experiment, simultaneously you also try with manual. No need to spare the separate time to complete the manual. Follow this exercise from next time onwards. Otherwise, again, everything you have to do again and again. So open your Word file and there you can just add your result. So simultaneously your manual is also completed. So if you have any doubt, you can ask. Otherwise, we will meet next week. If anything,
Okay, sir.
anyone want to
Thank you.
share, you can share your experience of 3 weeks, 4 weeks. कितने week हुए? 3 week हुए ना? If you any difficulty, if you want to convey any message, you can say no problem. Yukesh done, all done. Sivang all done. can share your feedback also, no problem. Your learning experience. Okay, so I wish everything going fine. We'll meet you next week. Thank you for joining.
Thank you, sir.
Thank you for joining.
Thank you, sir.
Thank you, sir.
I am here till last student. Yes, someone saying something? Nayak Dhananjan.
सर
Yes.
सर एक्चुअली सर आज है ना मैंने एक भी नहीं देखा है सर एक्चुअली मेरा लैपटॉप ही नहीं है मेरे पास
अच्छा, कुछ तकलीफ है लैपटॉप में?
एक्चुअली सर आपका मेल नहीं था मैंने आपको नहीं भेज पाया बाकी
हाँ।
फैक्ट्री को मेरा एक्चुअली लैपटॉप क्रैश हो गया मैंने फोटो भी साथ में भेजा था और मैंने ऑर्डर
अच्छा
किया
अच्छा,
था वो बोल
कोई
रहे
बात
सर
नहीं, नेक्स्ट वीक तक आप मैनुअल तो कंप्लीट कर देना, ठीक है, नो प्रॉब्लम।
सर वो तो कर दूंगा सर
ओके।
इसीलिए सर वही बोलना था दिखा नहीं पाया मैं
हाँ, अदरवाइज यू कैन यूज इन मोबाइल ऑल्सो, मोबाइल ऐप ऑफ मैटलैब इज ऑल्सो देयर।
हाँ सर ट्राई किया पर सर उसमें एक्चुअली मेरा लेक्चर भी इसी में देखता हूँ ना तो मैं
हाँ
जो
हाँ,
नोट्स करता हूँ ना वो फिर थोड़ा है
अच्छा अच्छा अच्छा,
इसके
ओके, नो प्रॉब्लम, नेक्स्ट वीक तक हो जाएगा ना?
हाँ सर बोल रहे 27 तक आएगा
हाँ,
कोई
कोई बात नहीं, कोई बात नहीं, नो प्रॉब्लम।
ओके सर
Yes, someone else? Pujan, you want to say something? Parthiv and Pujan.